In this lesson, we're going to talk about the standard equation of a circle, circles and coordinate planes. So the first thing, the standard equation of a circle, when x and y represents a point on a circle, so any point on a circle, and it's centered at the origin with a radius of r. So in other words, we have a point. We have the origin here, 0, 0, right? And we have a radius of r that stretches out to a coordinate xy. All right. Now I'm going to get rid of that 0, 0. Okay. The equation of the circle can be found using the Pythagorean theorem. And the way we do that is if we were to sketch a right triangle in here. Notice this side has a length of x. So from 0 to x is x. And this right here would be a length of y. Because from 0 to y is y. That means this length is y, this length is x. So we could use the Pythagorean theorem to find that r squared is equal to x squared plus y squared. Or x squared plus y squared equals r squared. And that's when it's centered at the origin. When the center of the circle is translated h units horizontally, so in other words, from taking the center, moving it there, so we're going out to here and saying, well, we've moved h units horizontally and then k units vertically, so we move up to k. That means now our center is at hk. Okay? And if we have that same radius r, all right, and we want to sketch a right triangle in there, notice this is still going to be a point on the circle, which we call xy. But these lengths no longer are x and y. Right? So if x is here and y is, say, there, then what we have is this length is the same as this length. And this length right here is a length of y without the k, so y minus k. All right, so this length right here is y minus k. Right, so we go out to y and then go back k, and get rid of that k piece. So we get rid of all the k, we're just left with this chunk. That's what we're doing there, which is this chunk. So this is y minus k. And this length right here is the same as this length. And this length right here is just x without all this h. So it's x minus the h. So the equation of a circle really is x minus h, that side squared, plus y minus k, that side squared, is equal to r squared. Still using the Pythagorean theorem. And that is the standard equation of a circle. X minus h quantity squared plus y minus k quantity squared equals r squared. Now, x squared plus y squared equals r squared is a nice shortcut if it's centered at the origin. Okay, that just means h and k are 0. All right. Otherwise, here the center is at the ordered pair h, comma k. All right. So let's go ahead and apply this here. Write the standard equation of the circle. Well, first thing I need to do, if I'm going to write the standard equation, that's in x minus h quantity squared plus y minus k quantity squared equals r squared. I need to know hk, and I need to know r squared. Well, hk is the center of the circle. And in this case, that is negative 1, 2. So hk is negative 1, 2. So I could write that in, x minus negative 1, substitute that in for h, plus y minus 2, substitute that in for k. Right? Equals r squared. What is r? Well, r is our radius. So here, looks like we got 1, 2. R equals 2. So we have 2 squared. So x minus negative 1 is x plus 1 squared plus y minus 2, well, that's just y minus 2 squared equals 2 squared, which is 4. And that is the equation of our circle. One kind of interesting thing to note, when we were in quadrant 1 back here, h and k, we had minus h minus k. When we're in quadrant, excuse me there. When we're in quadrant 2, or this quadrant, like if you're thinking of we're over here now, okay, well, you have plus x plus 1 and minus 2. So going up is minus for y, going to the left is plus for x. Okay, it's kind of weird, right? It's kind of counterintuitive. Going up is minus on the y, going down is plus on the y. Going right is minus on the x, going left is plus on the x. Just kind of something to note there. It's kind of counterintuitive to what you'd think there. So r squared here was 4, by the way, and hk was negative 1, 2. Okay. Let's try another one here. Bit of a different description. A circle is centered at 4, negative 3, and has a radius of 6. Well, center is hk. And there's our radius, so that means r squared is 36. So if I'm using my standard form, x minus h squared plus y minus k squared is equal to r squared. Well, r squared is 36. Substitute that in. Y minus negative 3 plus x minus 4. Well, two negatives make a positive, so it's going to be x minus 4 squared plus y plus 3 squared equals 36. All right, let's go ahead and try another one here. Okay, the point 11, negative 8 is on a circle with centered at 8, negative 7. Write the standard equation of the circle. Okay, well, if it's centered at 8, negative 7, we've got to get used to that just being our hk value. And so to write the equation, we need to know r squared. Well, we don't know r squared. The only other thing they tell us is an xy value. So what we do know is if we use the equation x minus h squared plus y minus k squared equals r squared, our final equation has to have x in it, and it has to have y in it. All right? But we need to know the radius. We know h and k. We know this is going to be plus 8, or excuse me, minus 8, and minus negative 7, which is a plus 7. But we don't know r yet. So filling in the things we do know, we know an x value, 11. We know a h value, 8. We know a y value, negative 8. And we know a k value, negative 7. We can now solve that. 11 minus 8 is 3 squared, plus negative 8 plus 7, it's two negatives right there, right? Negative 8 plus 7 is negative 1 squared equals r squared. So that's 9 plus 1 equals r squared. Okay, so r squared equals, make that parenthesis a little smaller there, 10. If r squared is 10, that just needs to be put right there. We now, let me kind of clean this up a bit. We now have our equation. So use what you know to find what you don't know there. All right. So another piece here. The equation of a circle is x squared plus 4x plus y squared minus 10y plus 4. Find the center and radius of the circle, then graph it. Okay, so last year you did this. You had a skill called completing the square. All right, and most students forget that over the course of a year because it's one you don't use a ton. But you'll use it next year in Algebra 2. And so I'm going to show how to complete a square. A quick review, so say a different problem here. If I had the square, say x minus 3, or x minus 3 quantity squared, if I had that binomial squared, well, if I were to multiply that out, or that would be x minus 3 times x minus 3. And we do this stuff, right? So the FOIL, that would be x squared minus 6x plus 9. Okay? This is called a perfect square trinomial. And it's a perfect square trinomial because it factors into a binomial squared. That's why it's a perfect square trinomial. Okay, and we could go into that being a square and everything, but it's a perfect square trinomial. When we're dealing with this type of problem, you're trying to make this quantity, right? If you think of your equation for a circle is x minus h squared. That would be your binomial squared. And then plus y minus k squared. That's another binomial squared equals r squared. So this piece right here is a perfect square. So what you need to do is you need to take your x values, x squared plus 4x, plus, like here, x squared minus 6x plus something. That's going to be a trinomial that's going to break into x minus something squared. And you also need to take your y. Okay, your y pieces here, where you have plus y squared minus 10y plus something. Okay, and that's going to break into your y minus something squared. And that's all going to be equal to, well, in this case, we're going to subtract this 4 over. Okay, so let me do that in a different color, so kind of stick with our color coding here. That's going to be equal to our r squared, whatever's left over here. Okay? So let's figure it out, right? What will make a perfect square trinomial? So taking a look at this, the way we could go from actually here to here is you just take half of your b term, and that gives you that 3. So I'm going to take half of my 4. That gives me a 2. That goes right there. And it's a positive 4, so this is going to have to be a positive 2, not a minus 2. All right. And then notice what you do with this, you square it to get that 9. So 3 squared is 9. And so you're going to square this number. 2 squared is 4. And whatever you add here, you have to add over here, right? Whatever you do to one side, you have to do to another. Okay? Now I'm going to have a problem here because I know what the graph looks like, so I'm going to erase some of that, and I am going to circle it up, kind of up here. I'm going to tail it off like make this a little smaller here. So I had the minus 4, and I'm going to have to add to it a positive 4. Okay? All right. Well, the next piece, so I've got my first part here. That's good. The next piece, let's go ahead and take half of this. Half of negative 10 is negative 5. And then square that negative 5. Well, negative 5 times negative 5 is positive 25. So I'm going to have to add 25 over here. So rather than putting that plus 4 there, you know what I'm going to do? Go plus 4 here. Okay, so we've got that plus 4, and I'm going to subtract 25. So I have negative 4 plus 4 is 0 minus 25, or plus 25, excuse me. So we added 25, and that's going to give me a positive 25 over on this side. Okay, I now have my equation. My equation is x plus 2 squared plus y minus 5 squared is equal to 25. All right, and Find the center. Well, the center, which is hk, equals, well, -2 and +5. Just the opposite of what you see in there, right? And the radius is equal to the square root of 25, or 5. That means if I want to graph it, I'm going to go to -2, 5, right there. I'm going to go 5 units each way vertically and horizontally. So 1, 2, 3, 4, and 5. 2, 3, 4, and 5. 1, 2, 3, 4, and 5. 3, 4, and 5. That's why I'm so picky about my work over here. Okay, and then what you do is, I'm not going to make you get a compass out. I'm going to kind of have you round off your circle the best you can. Okay, and it'll be a solid line, but based on what we're doing, I think that'll be good to go. I've got a little flat over here, but I think we got it. And there's our circle. All right, so completing the square there. By the way, that's in my algebra video lessons for 9.4. If you want to see a full lesson on it, you can check it out. But all right, let's go ahead and do one more here. Prove or disprove that this xy value, √3, lies on the circle centered at the origin. That means hk would equal 0, 0, containing 0.60. So if I were to graph this, I'd have a circle that centers right there, and it goes through the point 6, 60. Which means, since that's a horizontal distance, the radius equals 6. So that means my equation would be x minus h squared plus y minus k squared equals r squared. And hk is 0, 0, so that's x minus 0 squared plus y minus 0 squared equals r squared, or in this case, 6 squared. And anyway, it's centered at the origin. Just remember x minus 0. That just gives me x squared if it's centered at the origin, and y squared equals 36. The whole reason we write the equation, it didn't say write the equation, it says prove or disprove. Well, all we have to do now is substitute √3 in for x and y. If it's truly a solution, it'll make that true. Okay, so √3 squared plus √3 squared, does that equal 36? Well, that means you'd have √3 to the second is √9, or 3 plus 3. Does that equal 36? The answer is nope. They're not equal. So √3 is not a solution because it does not satisfy our equation. All right, trying another one. Prove or disprove that this coordinate xy lies on the circle centered at the origin. So once again, you're going to have x squared plus y squared. Okay, if it's centered at the origin, it's just x squared plus y squared, and containing 0.03. So here's our circle, 0.03. Okay, that is a horrible circle. Let's try again here. All right, that's a little better. We go through this point right here. It means my radius, if this is 3, is 3, which means, and we have 0, 0 as my vertex there. So my radius is 3, so that means r squared is 3 squared. So we get my equation, x squared plus y squared equals 9. So if I test these points, okay, 2 squared, so x squared plus y squared, or √5 squared, does that equal 9? The answer is 4 plus √5 squared is √25. Square root of that is 5. That does equal 9. Therefore, 2 root 5, 2 comma root 5 is a solution. All right. That's all I got for you. Good luck.